This is a lecture that contains things that many people will have already know. So pick and choose the things you know and the things you don't know. So we're going to start with basic computer concepts. And the first one is bits are bits. Okay, so if you have a collection of bits, and here's a hexadecimal number, uh, is this an address? Or is this an instruction? Or is this a data item? And the answer is yes, it could be any of those, and it just depends on context. So you can read that in from and treat it as data, and then transfer control to it and treat it as instructions. And this is important when you think about the boot process and other things that we'll see. So you turn on the computer. Built into the computer is the notion of uh, there's a BIOS from a known location that's part of actually the microcode of your processor, and it transfers it then reads the BIOS from this known location. It transfers control to it. So it treats the bits that it gets as data to read them in. Then it transfers control to it, treats them as instructions. And some of the instructions are to read in the operating system from a known location. So it has an address in there. Where is the operating system? The operating system is a collection of bits. It reads them in and it transfers control to them. And then you have an operating system. Another concept is the distinction between state and stateful and stateless. So state is another term of data for data. In order to execute, a component requires both executable code and data. And so if you have a component, then you have to furnish the data to it. And there are three ways to do that. One is you can have parameters, values that you send in. Second way is that you store those values on an external store database someplace. And a third is that it remembers it from the prior call. So there are sequences like you have to open a file before you can read it. Okay, so it remembers the fact that it's open, or it could remember the fact that it opened this file. It could also put that in a data, in a parameter, and store it someplace else. Uh, so a stateless component doesn't remember data from one call to another. So every call to the stateless component is like the first call to it. And so if you want to pass it parameters, they have to be, if you want it to do something on data, you have to pass it parameters or tell it where to find an external store. Computer has four types of resources. It's got a central processing unit, it's got memory, it's got disks, it's got a network, it's got network connections. So a central processing unit is the basic processing portion of your computer. It may have multiple CPUs, uh, but one CPU can be shared among multiple processes. Your turn, my turn, your turn, my turn, that kind of thing. And isolation between the processes is maintained by the operating system schedule, which is in charge of whose turn is it. There's also memory. It's got a fixed amount of memory. The physical computer has a fixed amount of memory and it's shared among processes. Process one takes, I don't know, the bottom megabyte. Process two takes the megabyte on top of that, and so on. And the isolation is maintained by hardware. So your process is given memory. The hardware knows your process, what your process is, and it only allows it to access the memory that you've been given. And if some other process tries to access it, then it generates an error. Disk is used for the storage of persistent values, and you can read and write values from a disk. And so disk can either be rotating or solid state. That's funny use because disk to me means rotating, but there's a notion of solid state disks. And isolation is maintained by routing all read and write requests through the operating system. An application programmer can't do reads and writes without asking the operating system to do it for it. And that keeps track of the access and which disk pieces of the disk you're able to get to. And then you have network connections. So part of the what you want to do from your computer is put a message on the network or receive a message from the network from other computers. And messages are tagged with identifiers of the sender or designated recipient. And the operating system is going to route those tags are used to tell the operating system how to route it. And we'll get into details on networks and things like that later. There are some issues that are specific to distributed computing. So if you are running in the cloud is inherently a large collection of computers that are distributed. And so any communication between the nodes in a distributed system has to be by messages. And so there are issues associated with messages. One issue is how do I know where you are? What's your address? So I know your name. How do I know an address to send a message to you? Because messages have to be tagged with specific addresses. They can't be tagged with names. So there's a mechanism to change names into addresses, but that's called discovery. Uh, how do you scale? You have a distributed system. You have several instances of your application running on that distributed system. It's not enough. It's a popular application. So you want to create more instances of that application. What are the message communication patterns? How do you arrange for a message to be delivered to a known recipient? And you still want to maintain security and you don't want to overload it. So there's a pattern associated with it. And the question is, how do I get a message to you? And I have to follow the pattern. Again, we'll go into this in more detail. And then components fail. And so if a component fails, then you need to discover that it's failed. You don't want to send messages that aren't going to get acted on. And then, ideally you repair it. Again, we'll get into some of this, how do you do all that? And then finally, let's talk about quality attributes. So a quality attribute is a measurable or testable property of a system that's used to indicate how well the system satisfies the needs of its stakeholders. So it isn't what the system does, it's how well it does it. And there are dozens of quality attributes. There's a standard, and the last time I looked at it, there were 24 different quality attributes, and you can generate a quality attribute by putting ility at the end. So performance is one that doesn't have an ility at the end. Availability is one that does have an ility on the end. Scalability, uh, I don't know, interoperability, just you can go on and on. So what's performance? Well, performance is measured by latency. How long does it take to respond to a request? And it's measured by throughput. How many requests can I do per unit time? What's the measure of number of operations per unit time? And availability is measured by the percentage of time a system is available for service. So you know about 24/7. It may be that you want to have a system available in terms of, you want to specify it in terms of nines. So 4 nines is 99.9999, did I do that right? Percent of the time the system is available. So you would have a specification like that for availability. And that's what we're going to say about the preliminaries. We'll get into some of these in great deal of detail. Others, this is things you should know, and we'll apply them. We won't talk about the details of it.